So what's up, Jay? How you doing?
Good. How are you?
Good, good. I know you pretty well. Marco knows you pretty well, but I don't know if a lot of our viewers know you. Could you introduce yourself? Because you're kind of the big dog around there.
Sure. Jay Evans. I founded Keirton, which is the parent company for Twister Technologies, in 2008 with a business partner. Been in the cannabis space. Grew my first plant in high school, so it was probably 1995, 96, and then started growing quite heavily after that. 2008-ish, 2007, 2008, we had a major problem with trimming. So we found that we needed to have a lot of trimmers. And so one of the things we decided to do was develop or perfect a trimming machine. And so that's when the Twister T2 was first launched. We actually didn't sell any for the first 2 years, just for our own internal use. And then eventually things led to us selling them to the market, and that brought us to here. So
Awesome.
yeah.
Well, I know that we have a lot to cover, and I'm really excited to go over the information here because you've had so much experience in the post processing side that I really want to pick your brain because I think one thing lost on a lot of like building out grows and running grows, a lot of people let slide the last most important 10% of everything, which is preserving the quality of the product and making it as presentable and as high quality for the end consumer. So yeah, let's just dive right into this first slide. You mentioned that there was an issue with, getting trimmers that were up to speed or at least had the production speed necessary to go through all of the cannabis in a timely manner. What is like one of the more important benchmarks that you've seen like your automated equipment provides versus like just standard hand trimmers?
Well, there's the obvious one of speed. Consistency is also quite important. The managing of people is a challenging one for most operators, and that becomes difficult. Obviously, it's a very high turnover in most companies. It's a very high turnover part of the business. So in terms of employees turning over, it becomes challenging. And so any way you can automate that, it obviously brings advantages.
Right. And I have a couple metrics here, like by hand, we're going to be looking at maybe at most like 2.75 kilograms in an 8-hour shift, in a full 8-hour shift. Like how long would it take, say like a T4, one of the medium small models, to go through like 3 kilograms of material?
Yeah. So the T4 is kind of like our mid-sized machine. It'll do 7 to 10 pounds an hour. And so obviously we're talking between kilos and pounds, and it gets challenging, but and then we have a machine that'll do 150 pounds an hour. So it kind of depends on the throughput someone needs. When we have machines that'll do less, we have a machine that'll do roughly a pound an hour. So there's obviously a range in there. And there's a variety of ways of doing it. Like we produce a machine which is, we call it a throughput style machine or a tumbler style machine, and there's other ways of doing it. But we found over the years that we've tried everything. When we build a machine, we'll go and buy every other product on the market and we'll benchmark it. So we actually benchmark all of our machines against our T4. So any machine that's on the market right now, we benchmark against the T4, and so we get a pretty good idea of where it fits in the market. And it's I would say that when we're talking about the T4, I would say the T4 is probably the best machine on the market right now, in my opinion. And I've used them all. So,
and honestly, I'm going to agree with you, especially for like the mid scale and like the mid to large scale craft growers. I use the T4 because that's kind of the first model that has a very good, efficient vacuum system on it. And we really liked using that because we didn't have to spend so much time trying to get this cannabis perfect. But one thing that I did recognize while using the T4 when I was growing commercially was it's all about the quality and the state of the cannabis before you put it into the machine. Because there's a lot of, like stories out there, like little nightmare stories of like how trimmers are not as efficient, or they don't give you the quality of material that you get from a hand trimmer. And once we had our machine dialed in, it was better than having to hire seasonal workers that hadn't seen a bud in like 4 months. And it takes them like, hours the first couple weeks. And then the next couple of weeks, they're just as good, but it's still not the same throughput. So like, what are some of the main considerations before trimming even begins?
Yeah, good question. So number one is the flower quality. Obviously, if you don't have good flower, then it's going to be difficult to produce anything good in the output of the whole process. So Flower quality is number one. Most people these days can grow decent flower, and then they drop the ball in the 1 yard line, which is the post harvest, right? So it's the drying, the trimming, the curing, sorting, like all that end stage is where most people make a lot of mistakes. And we've done, we've taken Reddit, we've gone through there, we've pulled out all the negative Reddit reviews we could find. So we pulled out like 2,000 negative Reddit reviews, and of those, the vast majority, like 80%, were things that were post harvest related. And so it's really clear that there's an issue in the post-harvest side. So in terms of getting good output from, say, a trimming machine, number one, you have to have good quality flower. Number two is the drying. So drying is critical, and most people, I would say a lot of people make a mistake there. And so if the flower gets into the machine too dry, it'll get over trimmed and it'll get eaten up. If it goes in too wet, it won't get trimmed very effectively. And so there's different ways of doing it. We talk about like moisture and measuring moisture and all that, but really fundamentally, if the flower, you want the stem to almost snap, like it doesn't snap yet, but almost snaps, and the leaves are a little bit crispy. If you process the flower through machine in that condition, you'll get really good results. Challenge is most people will over dry, then it turns the flower to dust, or they'll under dry, and then the machine has to sit there and work really hard at trying to get the leaves off because the leaves are so pliable and they're bending and twisting. And so we always say, stems almost snap. Leaves are crispy, stems almost snap. And if like you remember that, leaves are crispy, stems almost snap, then you should have really good results with that. The next thing is people often will go and take their flower from the dry room and then they'll move it into a room with a different environment. So it'll be a higher humidity or a lower humidity. Typically a higher humidity is more problematic. And when you move into that higher humidity, the flower instantly pulls that moisture in the flower and it turns the flower into, it makes it hard to trim. And so we go back to good quality flower, good conditions in the dry room, and then good environmental controls in your trim room. And so we like to say, if you could actually trim and dry, if you could dry, trim, and cure all in the same room, that's the ultimate, because typically you'd have the same environment the whole time. And then last is just the equipment you're using, right? So there's obviously a lot of trimmers out there. There's probably been 25 different trimming machines or different trimming machine companies in the market in the last 20 years, and there's not many left. And so there is, you have to buy a machine that's quality. And the last thing is, I think that you kind of touched on, is it starts off quite good, and then as you move down, say 3-6 months from now, maybe a year from now, the quality starts going down. And that's typically two things. One is just maintenance of the machine. Like the machines need some sort of like cleaning it. They have to have replacement bags. There's air systems that are typically involved. And then the other piece is just user or operators. We'll have turnover. So one person gets really good at it, that person leaves or gets promoted. You have a new person, and then they don't know all the nuances and tricks that the previous person used. And so like the SOPs typically aren't followed well, and then you get degradation over, say, we usually see within a year. We have to go back to a lot of facilities every year just to give them a little pep talk on a little reminder, a little refresher on how to get things back to where they were when they first started.
Yeah, and I kind of see it as like drip irrigation. A lot of like kind of newer growers, they don't understand you got to change out your drip irrigation every 3 to 4 cycles. And this is a piece of equipment just like that. It needs to be maintained. Someone has to be on top of the preventative checks and maintenance. You brought up a good point about the quality of material before trimming. What I've found in a lot of grows is they will dry their cannabis to almost like the quote unquote ideal for sale before it even goes through the trim process. So it's a whole different, it's a dry product, not a ready for consumer product. So the metrics on it should be different. When it comes to moisture percentages, I like working with hard numbers. What are the kind of like the water content numbers and the moisture percentages that you're generally looking for? And then one thing that, kind of I think is lost on a lot of people is water activity too. So could you explain like what the ideal percentages people should be looking for as far as water content or water activity before they do a trimming process?
Sure. So we used to use moisture analyzers. So we have the $10,000.
Yeah, I got one on the screen. They're pricey.
Yeah, that one right there. Yeah, sure. So we have one of those. We've tried the wood probes where you probe it into the flower and try and take a measurement. That's really not accurate at all. And we advise people to use that for a while. So we apologize for that because it wasn't really the best way of doing it, but it was the only thing we had and it was cheap at the time.
Right.
So we've actually moved. And so now we really rely on water activity a lot more. The problem with the moisture analyzers is they're, number one, expensive. Number two is you have to have a standard for it. And everyone, not everyone, but people often use different standards. So how long it'll heat the flower, how long it will, or how hot it'll get. And so you don't always get the most accurate numbers of that. You could have 3 of those machines side by side with the same flower, even the way you prepare it. If you grind it smaller, There's so many things that can change. So we find that using moisture percentage isn't super helpful most of the time. And that's why we go back to the stem almost snaps. Like it has to have some moisture left in the stem. If you don't have moisture left in the stem, what will happen is when you put it through an automated trimmer, the flower will fall apart. It'll start breaking off the stem. But there's moisture in it. It keeps that structure. But that in turn also helps you in the next phase, which is curing. You want a little bit of moisture left in that flower to slowly wick out of the flower. If you pull all the moisture out before curing, well, then curing isn't be that effective. And so for us, we want to make sure that when we're measuring moisture content or water activity, again, it's just that stem almost snaps and the leaves are crispy. And now that is typically around 12 to 13%. And then water activity, that's typically around 60 or 0.62 to 0.60, so somewhere in that 60 to 62% humidity range. And so when we find we're in that range, you can have, another problem is you could have very high moisture content, but all that moisture content could be in the middle of the flower, right? And so it's kind of misleading if when people are trying to use moisture content and water activity to measure their flower before trimming, it can be misleading because you could have a lot of that moisture stuck inside the flower and it could have a really high moisture content, and you could think that you're not ready to trim yet when you actually could. And so,
and the bud morphology plays into that too, right? If you have skinnier, kind of more sativa type buds versus like the rounder, densely stacked indicas, you kind of have to play with those numbers to find the best inside and outside moisture activity and moisture content balance, correct?
Certainly. And so we don't typically we'll measure water activity in our dry room. So we'll use a cure puck to measure our water activity in the dry room. So we want to pull the flower out of the dry room when the water activity is roughly like say 0.62, 0.63. We pull the flower at that point, we'll trim it. And so we have a proven process that we've developed. So we have a grow facility down the street. So we actually grow ourselves as well. So we've been growing there for 15 years now. And so everything we build, we test in that facility. And everything we build because we need it for growing essentially. And so the cure puck was what we put, so the proven process is it involves a cure puck. So we'll start with measuring the water activity in the dry room, and we'll pull the flower out when the water activity is 0.62. Then we'll go into trimming. And so the flower has to be, again, stems almost snap, but not snapping, and the leaves are crispy. Then we're going to trimming there. Typically we'll trim all the smalls for sure with a machine. Sometimes we'll trim tops by hand, or we'll do a light trim on the tops and then finish them off by hand. Then we go into curing. And for us, the stages we follow are really critical because it's taken us a long time to perfect this process to get really good high-end flower on the output. And you can see some of our flower in some of our videos. Like for the most part, we produce some pretty nice flower.
Pretty nice. Yeah, I got to say it's pretty nice. Yeah, I mean, it's also, super important that people reiterate that you can grow the best flower in the world, but if you lose all of that quality in your dry trim cure process, it's moot. You got to make sure that the last 10-yard line, you're really focusing on the environmental parameters and ensuring that it's as good a quality going into trimming, and it becomes a better quality, like a usable product by the end without degrading or becoming too dry. Now, we've talked about like putting stuff into the machine. Now, the differences in machine, because I know this is a daunting thing for a lot of people. They're like, what type of trimming machine should I get? I don't understand like the numbers on that. Can you just explain quick and dirty like some of the differences between like the T series and the batch 1 series, and like what the differences are in setup and what would be good for, like small scale versus mid scale versus, giant greenhouse glasshouse grows? Sure.
So there's kind of two primary methods of trimming or automated trimming. There's what we call single piece flow. So that's it's the same way as like Subway sandwiches or like Toyota or any modern production facility. One piece comes in and it comes out the end of the assembly line. And so if you look at the T4, that's how it works. You drop one flower in and another flower falls out. There's advantages of that. Big one is quality. So quality control. You can change. You don't do it. So let me stop. The other side is batch processing. So there is a single piece flow versus batch processing. So batch is it's like your dishwasher at home or your laundry. You load a batch in, you hit go, and it runs and spits it out. The challenge is when you do it that way, you can have the batch. You can have the batches between batches can be a lot of inconsistencies. You can't adjust quality issues on the fly. It's not as fast. And so that's why in most modern manufacturing, they don't do batch processing. It's all single piece flow. And so our primary products, our primary trimmers are single piece flow, but we do sell batch style machines. And the advantage of the batch style machine is, number one, they're quiet because they don't have a vacuum system typically. And some people just like doing batches. They like throwing it in, they got it figured out, they come back in 15 minutes and it's done. The disadvantage of that though is you now have this big bulk amount of flower you have to quality control. Whereas when you're doing single piece flow, it's coming through and you're doing quality control as the flower is coming out, and you can make adjustments as you have to. And so if I were to choose a machine to use and noise wasn't an issue, then I would choose a machine like the T4 versus say a batch style machine.
That makes sense. I've seen the batch style machines a lot more in, say, large scale hemp facilities where they know they're going to be running 20 pounds at a time, 20 pounds at a time. But for the craft guys that have multiple different strains, they have to adjust the machine between strains to ensure the best quality. I guess the single flow definitely makes a lot more sense for the flexibility. And
they're faster too. Like head to head, a single piece flow machine versus like a T4 versus a batch style machine. The T4 is going to be way faster. And so again, there's the disadvantages of the noise, but you can mitigate the noise by moving the vacuum system into another room. So we often will build a room around the vacuum system, then the T4 will sit out in the open, and then it brings the noise down and everyone's happy. So
keeps the dust down too, because that's one consideration when you're using the vac system.
Yeah, there is. So our newer, bigger models, like the T0, for instance, has a full HEPA filtration system in it. So it's like it's hospital quality air. Like the air is actually cleaner coming out of the machine than it's incredible how well that machine works.
Awesome. So one thing right here, I got a picture of these two buds, and this is the most common complaint I get from growers that are new to using automated trimming. They realize and understand that using all of this human labor, especially seasonal labor that does not have, like an everyday feel for the trimming, they find that like, okay, I want to go into an automated trimming system, but this is the nightmare horror story that I hear from all my buddies that are growing is, it's going to round out your bud. It's going to, reduce the quality. Your trim ratio is going to skyrocket. Can you explain how to avoid these common kind of missteps to make the cannabis look like the bud here on the right instead of the bud here on the left?
Sure. So I think we own that in a sense. Like we didn't do a very good job for a long time teaching people how to use the machines correctly. And part of that was for until a few years ago, we couldn't advertise the cannabis space at all. So none of our marketing material, none of our content included any material at all on how to use our equipment. We couldn't even talk about the word cannabis. So unfortunately, we've kind of fallen behind, and a lot of people use the machines, use them incorrectly, or they buy a machine, they pass it off to someone in their facility, they expect them to figure it out, and then they have issues like you said, like the flower gets rounded out. So that flower, that image there is the exact same cultivar, grown the same. It was just trimmed differently. So on the left, it was trimmed by another machine we don't make, and that machine is their claim to fame is really tight, close tolerances. The challenge is it will round the flower out and give it that rock polished look. And so our machines, you're able to adjust the distance away, and then the other piece is the process. So with any machine, 50% of it, well, I should break it up. It's probably 33% is the flower quality, 33% is the machine being used, and 33% is the process being used. And so let's just assume that flower quality is all the same. So now you're left with the equipment and the process. And then so most people, so you already have the equipment now. So now the last piece is the process. And the process is so critical. And that's where most people make the mistakes. And so that flower there, on the flower on the right, has all the texture and all the shapes, nooks and crannies to it. And that was trimmed on a machine. That wasn't touched up by hand. And so again, and that was the process. So the process in these two was the same. It's just the different equipment. And so I'm very confident I could make any one of our machines, even any machine on the market, work decently well if we follow the right process. And it goes back to that again, what I said earlier, the stems almost snap, leaves are crispy, and then how the machine's set up and run. And so a lot of times people will run the machines incorrectly, or they just give it to someone who's fairly new to the company or inexperienced and say, hey, just figure this out. And then they end up eating all their flower up. So,
right. And I've seen a lot of the times, going back to the last slide, guys throwing material into the machine that is basically at a moisture or water activity percentage that is basically shelf level instead of being at the trimming level. So yeah, stems almost snapping, leaves a little crispy. If we could clip anything, we got to clip that one.
Yeah, and a common thing is people, if you're trimming and then going right to bagging and it's going out the door, then yeah, maybe you want to have the moisture content or the moisture content ready for sale. But
Right.
if you're curing, then you shouldn't. You're going to have to pull some of that moisture out still, like slowly, and that moisture is important for the other processes in curing. So again, back to the process, following, like right now below there we have dry, buck, trim, cure, grade, sort. That's how we like to do it. Now you can move those around if you want. And so for instance, you could dry and then cure and then trim. The challenge with that is your trimming bills will typically be twice as big, because the labor goes up so much, because trimming cured flower is gonna be really sticky. The scissors stick to it. Everything's just gooey and gummy, and it takes forever. And so like we see all the time we used to see when we would cure first and then trim after, our trimming bills were always twice as much as they should have been.
Increases the maintenance on the machine too at that point, I'd imagine.
Oh, everything's just harder. Yeah, and even trimming by specifically trimming by hand, it gets much harder. So yeah, agreed.
Yeah. So one thing that I wanted to touch on is like a lot of these more sophisticated tumbler style trimming machines, and most trimming machines, honestly, at this point, come with some sort of a vacuum system. And I've also found that this could be kind of the Achilles heel of the process too, when guys don't understand how to adjust the vacuum pressure in accordance to like blade distance. And then and honestly, the entire process, like you said, it should be like kind of like a factory setting where it goes in one way and it goes out the other, but they don't have the conveyors to allow them to have the consistent flow into the machine. So they'll throw in like almost like a batch style, like 1 pound at a time, 3 pounds at a time, but it should be more consistent. Can you go over like how these vacuum systems work and how people can adjust them, and any other tips on automating the entire process?
Yeah, so as far as feeding, like when you have a single piece flow system where it's one piece in, one piece out, the feeding rate is critical. So if you're not feeding it consistently, you're going to get really lumpy output, and so you're going to get untrimmed, over trimmed. And so feeding it really consistently is important. So that's why we use something called an input conveyor, so that conveyor constantly feeds it. There's other things we have as well, like an auto hopper that will feed that conveyor. So there's ways you can fully automate that whole system. So feeding is critical. As far as vacuum goes, I personally, like, I've done a lot of trimming and been in a lot of, we visit roughly 500 facilities a year. So we've been doing that for years. And so we've seen a lot of different things out there, a lot of different facilities. And so for me, the first thing I do is I just turn the vacuum up as high as it'll go, and I just move the flower through the machine faster. And so some people like, oh, they want to turn the vacuum down, they want to get more gentle, but that works for some people. But for me, I just turn the vacuum up as high as it'll go and move the flower. I want the flower to move through the machine in 45 seconds or less. And so if it's in there for longer than that, it's just spending unnecessary time getting tumbled and beat up. And so that's another reason why I like the single piece flow machines, is because the flower will move in and out very fast, versus a batch style machine. Some of them you'll see, it'll just sit there and spin forever. Now, there's advantages to that, but in my opinion, I'm all about like, how do I cut every little penny I can out of this and every piece of cost I can, and how do I get as fast and as efficient as possible? And so turning the vacuum all the way up for me works the best.
That makes sense. I hadn't really considered that, but I mean, the whole point of using this automation stuff is so we get maximum throughput with the highest quality. So instead of making the throughput suffer by slowing down the vac process, you can, like you said, modulate the amount going in, which gives you the same result.
Certainly. And some people get concerned that, it's going to suck off all the crystals, and don't get me wrong, with automation, there's going to be a difference in, if I were to needle poke, hand trim a flower holding the stem versus running it through automation, there's going to be a visual difference to a really trained eye. In terms of lab testing, you often can't tell the difference. You often can't test the difference between machine trimmed and hand trimmed. It's plus or minus 1%. We've done hundreds of tests, and it's very hard.
I've seen it firsthand too. There's very little, if any, difference at all in COA.
Like plus it can go the other way. It can be the machine trim can have higher COA sometimes. So, but you can, if you, the main problem is if you leave the flower in there for too long. If it just sits in there forever getting tumbled, you're gonna do damage to it. So
again, it goes back to your actual, how you feed the machine and how you're operating the machine. Once all of this cannabis goes through the machine, we have it out and ready, and it's not going to go directly into packaging, and we want to cure it. This is the slide that I'm most excited for, because I remember seeing this product at MJ BizCon like 2 years ago, and I was like, no doubt, like, why has no one made this before? Like, growers have such like a hard grasp on trying to maintain environmental controls in the room, trying to maintain environmental controls or like fertigation controls with like GrowLink, Trollmaster, Priva, Arroya, but no one has integrated the curing and the drying side of that stuff into those data metrics. And you guys finally have. Can you explain like the theory of the cure puck and how it operates?
Sure. So for us, let me back up and why we developed it. So we were, for a long time, we didn't believe in curing. I personally thought curing was.
I was in the same boat. Yeah, just get it out, get it to the consumer. Yeah.
Yeah, it's just, call it bro science, call it whatever you want. I didn't think it was necessary, and I didn't see a big difference in flower. One day, about 5-6 years ago, I was at a friend's facility, and his flower was incredible. It was so sticky and it smelled so good. And I was like, "What are you doing?" He didn't want to tell me. And so finally, he started showing me. He's like, "Yeah, I cure." I'm like, "Really?" So he showed me how he was doing it in black and yellow totes, and he was just burping these totes every day and burping them a lot actually in the first few days. And so, anyways, I started experimenting with it, and like his flower, we were growing the same genetics, the same LEDs, all this stuff was the same, or the same. We didn't have LEDs then, but same lighting, same everything, and he was just producing better flower than us. And so I was like, "Hey, there's something to this curing thing." And so we started playing around with it, and we started doing a lot of testing. We started measuring the gases. We were measuring ethylene and CO2 and ammonia and all these different gases, and trying to figure out what was actually being given off and how do we optimize this. And so for about 2 or 3 years, we got a lot of data, and we built a bench model, automated curing system. It's kind of big and clunky, and then eventually we started realizing, okay, yeah, there is something to this. We're getting way better flower through this process. And so eventually we wanted to make it smaller. And again, this was just for us. Like, we had no intention of releasing this to the market at all at the time. Right. And then how do we make this thing more portable? And then we started looking at how do we get away, like we have these black and yellow bins. Can we get into something more sealed? And that's when we start looking at these barrels. We talk about that more later. And so eventually, with all this data we started collecting, we started realizing that, yeah, we can automate this and make it consistent every time. Because the challenge we were having is sometimes our flower was perfectly cured and sometimes it wasn't. And we kept missing the mark. And where we realized we were missing the mark the most was in drying. We weren't, and for us, if we were to stretch the dry out to say 14 to 21 days, then we got more consistent with drying. But for us, this market's tight. And so we're trying to get every minute we can out of our day. And we're trying to condense things as much as we can. And so not to the point where we're degrading quality, but to the point where we just start to. And so for us, we realized that we want to dry in 10 days if we can. And because of the cycles of our room. And so we started figuring out how do we dry in 10 days perfectly, and then do the final stage of curing for another, say, 10 to 14 days in curing in a separate stage. And so that's kind of what we perfected over the last, call it 5 years. And that's essentially where the cure puck came from. We realized that we have to figure out on this curing side, how do we get this more consistent? And more importantly, some of our flower, the consistency was important, but also the shelf stability of the flower. So like when it goes in packaging and then sits on a shelf somewhere, we want that flower to be the same as when we packaged it. And so what was happening for us and others we found is they would package the flower too fast, then it would go in the packaging, and then it would off gas while it's in this packaging for 2 months. And then when you open it, you get a bit, you can smell it. Flower smells good, but there's a bit of a funk to it. And so that's often the gases that are built up in there. So we had to make sure we got those gases out. And then the other piece is the moisture content. So we don't, when the flower is, like I have some flower here, like when we travel to all these facilities around the world, we'll often stop at the dispensaries in their region and buy all their flower and just see like how their flower looks on the shelf. And it's incredible how much flower we buy that's crumbly and over dried. Yeah. And so for us, like this flower here, this is like, it just crumbles to dust, right? And that's so common in so many of the packages.
All the ink bags out there, yeah.
And it's not necessary. Like it's you can have flower, like I have some other flower here that is just squishy, and its stems will snap. Like the stem snaps, it's squishy like a marshmallow. It'll puff back up. It'll stick and hang off your finger.
Yes. Yeah.
This is how we like our flower to be. And so if it's not hanging off your finger, and it should be able to hang off your finger in 2 months from now, there should be no reason if you do it right, there should be no reason you can't make it hang off your finger in 2 months. And so, yeah, anyways, so we developed Cure Puck. The Cure Puck has been super helpful for us in nailing that metric, and also on the dry side. We put a Cure Puck in our dry room, and we monitor our dry room, because the problem with a lot of the devices that are out there right now is they're not super accurate. So like the sensors we have in the Cure Puck are plus or minus 1% accuracy. Most of these, if you go and buy like a sensor push or any of these other devices that are on the market, they're all plus or minus 3%, 4%. And so like we're trying to dial it into like really precise numbers. And when you have that big range, it's hard to dial it in. And so we even find this, we'll take Cure Pucks into a lot of facilities and we'll put it into the dry room. And then we'll look at the controller they're using for their dry room. Their controller's out by 2, 3, 4, 5, 6%. And so it's hard to produce really good quality if you can't measure well. And so,
well, it's two sides of it. I think people are, they understand they need the proper environmentals in their dry room and their cure spaces, but I don't think they're seeing the difference in resolution where you can have a room sensor that is made for like 40,000 or 4,000 square feet. And it's almost impossible to get that tight resolution. But when we have a Cure Puck in a set amount of volume, then we can get much more detailed data. And, you know, everyone's going to GrowLink or TrowMaster or Priva. They're trying to gather all these metrics to be as reproducible and consistent as possible. Mm-hmm. One thing that's been missing is the actual, like where the bud is sitting, in the tote bin, in the barrel. The environmentals in there are more important to the quality of the bud than the actual environmentals of the room. I think this is best illustrated by showing a snippet of the web app. Marco, if we can pull up that picture of how the web app looks when you're using the Cure Pucks. This is one thing I'd want people to see. So can you explain this first graph for us?
Sure. And so there's a web app and there's an app for your phone, so iOS or Android. And so I prefer to use, when I can, I prefer to use the web app because there's better resolution and better data in it. And so there is these, you can see the square bars, the square wave there. That's essentially the puck burping. So that's giving you the indication of when the puck burped. Then the blue line below that or in the middle is the actual moisture or the sort of the water activity or the relative humidity in the chamber. And so for those who don't know the difference between relative humidity and water activity, it's essentially water activity is the equilibrium of the relative humidity over a period. So like essentially, I'll give you a quick demo on how you would do this. You would take a turkey bag, load a bunch of flour into the turkey bag, put a hygrometer in there, seal the bag up, and let it sit. Technically, you have to let it sit for 24 hours, but if you let it sit we find within 4 hours, you'll get a pretty good indication of what the water activity is. So you let it sit and then read the RH number after that time of equilibrium. So what's happening is the flour is giving off moisture to the air or pulling in moisture from the air. Essentially, it's stabilizing, equalizing the headspace in that bag. Mm-hmm. So once it stabilizes, you take that reading and then you move the decimal place over 2 spots. So if it says 63% RH, it's actually 0.63 water activity. And so what we're doing is we're measuring water activity with this. And you can see that the moisture in that graph there, it climbs, we burp, and then it falls. It climbs, burp, and then it falls. And so we keep doing that. We keep burping that moisture out until it flattens out to the number we want. And so for us, depending on if it's really dense flour, we found that we want a slightly lower water activity number. So we want it to be, say, 58 to 60. And if it's larfier flour, between 60 and 62. We find if we put the denser flour in a higher water activity, you can sometimes get a bit of a funk smell. Like it's in 99.9% of people will never smell it. But if you're a broker and you buy cannabis all day long and you take the bag out into a field somewhere, you can almost smell as a little bit of a funk smell. So it's important that you really monitor your water activity. And so what's happening here is it's burping off that moisture, and then eventually the graph flattens out, and then you know, okay, the moisture is no longer being given off, and you've allowed the water inside the flour to slowly wick and stabilize. And what happens is that water binds itself into the flour, and when it binds itself into the flour, it stays in there longer. So if you were to expose that flour to, say, really dry air, it's not going to just give off that moisture really easily because that moisture is already bound in it. So if you find flour that's been cured really well and not cured well, and it's the same water activity and same moisture content, and you put them on a counter in a dry environment, the one that's been cured well will hold that moisture in much better than the one that hasn't. The one that hasn't will just give off that moisture really easily.
And I think that's one of the reasons why you get these packages with super overdried bud is because they didn't go through this cure process. They didn't allow this cannabis or this bud to reach its equilibrium. So either on the shelf or anything, if there's like a pinhole leak in that bag, it's just going to gas off all of its water.
Certainly. And we've done there's a video we've shared where we take tortillas, because tortillas are really easy to do. And we've actually locked the water into the tortilla with curing. And you can see the visually, one tortilla looks like it's got moisture in it, the other one doesn't. So it's an easy test. And we actually encourage people to practice curing with tortillas, because it's an easy way of doing it. So this next graph here,
that is a legit tip for people if they don't want to waste cannabis. Use flour or corn.
Either.
Okay, good to go. The second graph I wanted people to see, and the one thing that I really love about this app is that you could look at all three of the graphs. We'll go to the third one here in a sec, but you could see the correlation. Like you see during that burp phase, you see these little dips. Can you explain this particular graph?
Yeah, this is the CO2. So we've measured ethylene, CO2, and we've measured a ton of different gases. There's gases that are certainly given off, ammonia, CO2, or ethylene. The challenge with them is to measure them. It's quite expensive, and we found that CO2 is a really good marker, one of the best markers for the off-gassing. And so this is the CO2 graph. And you can see when the flower was first loaded, it got up to over 1,200, 1,300 ppm. And so at every burp, you'd see we'd burp down off some of that CO2. And eventually, as the cure continues and it gets to the end of the cure phase, the CO2 is now stable at 500 or ambient or whatever or here it's 800. And so sometimes one of the things a mistake people make is you have to know what your ambient CO2 is. Like in most areas it's 450, but if you're in a dry room or in a cure room and it's next to a grow room, sometimes the facility has an elevated CO2. So you can see here, because it flatlined at 800, they probably had an elevated CO2 in that room.
And if that room has one or two workers in it at any given time, you're always going to be above baseline. So you need to set your own baselines with this type of data.
Exactly.
And so the last graph, if we can take a look at that, this is kind of one of my main justifications of getting a product that does what the CurePuck does. This is the room data, right? Can you explain why it's so sharp like this? Like it's a pretty wide range that room's been swinging that entire time that all the other processes were happening.
Yeah, so this room is swinging like 52 to say 65% RH. And so you'll see most facilities we go to, the RH in the room will swing dramatically. And just because either undersized or oversized dehums, or just the way it's being controlled, the deadband on the stat is really wide, or whatever the reason is we see a lot of fluctuation. And this is actually quite stable. Some of them are way more dramatic than this. And you open the doors, or people come into the room, or then there's a room next door, or whatever. And we often see this really inconsistent control. And so one of the things that the CurePuck does is when you load, people already know this, is when you load flower into a chamber, you're essentially buffering against that room environment. So you technically could cure in a room. Like you don't need to put it into a chamber, but it's very hard to control the room and make the room stable enough to get the results you want from a good cure. So, and that's why we put things into chambers.
Awesome. I do believe you have quite a bit of CurePucks behind you. I would like to see like kind of how you guys run CurePucks ideally, since you guys are R&Ding this stuff. Like how have you guys set up some of the CurePucks in, say, for your flower and your guys' spaces? Could we transition over to that?
Sure. Yeah, no problem. So we've tried black and yellows. We've tried all these different containers. We've tried barrels. We've tried these different drums. My favorite in different sizes. So you can go from you'll see there's a 5-gallon or 35-gallon drum, craft barrels. There's a 35-gallon blue barrel there. There is a sea vault. There's a glass jar. Actually, if you go back to that glass jar, Aaron.
Oh, that's sweet.
So we use a glass jar quite often just for testing. So like we'll go and this is how we measure the water activity. We'll load a bunch of flour into the glass jar or into any small container, put the CurePuck on it and measure that. And we'll measure it over, again, 24 hours. Typically we'll cheat and do it within 6, sometimes 4, and we'll get a good idea of water activity. That flower's been there for a long time. So what's the number on there, Aaron? You zoom into it. So it's 49. So it's really dry flower. So that flower will just crumble to dust. And so we've been pumping that for weeks, trying to see how low we can get it. Then the next is a sea vault. You just basically drill a 2.5-inch hole in the top of anything, or in any container really. So that's stainless, and we just drill a hole into that and stick it in the sea vault. 5-gallon buckets are common, and then the blue barrels are typically for people who are GMP or you have some pretty strict standards or cleanliness is really important to you. Right. I prefer the craft barrels. They're a PE line, so there's inside of it there's a liner. So you could go to Uline and buy a barrel, but then the problem is it'll be craft material on the inside as well. So these are a little bit more special. And then puck actually threads into the port, into the top of the barrel. So it just fits perfectly into the top. And then you'll fill that barrel at least half full to 3/4 full. It's really important. A common mistake people make is they use the wrong size chamber for the amount of flour they have. So if you go in an ounce of flour into that big barrel, you're going to get terrible results. So you have to have the flour filling at least 50% of the container, ideally 70% of the container. And then you'll have this headspace above, and that's what you're monitoring. You're monitoring the gas in that headspace.
Right.
And that's where you're pumping that air out of. And then the black and yellows are all obviously common. Challenge with those is obviously you can't seal them very well. People will put foam tape on them and stuff, and that works okay. The other problem with those is the static from them is annoying, because if you use a liner, it works well, but if you're not using liners, the static is super annoying. And then they just off gas. They don't smell great either. So
the plastic of the totes themselves.
Yeah. And they work, but they're not our preference. And if you go back to the barrels for a second, one of the things that I like most about barrels is they're on a roller, so you can actually roll the barrel in this rack, and so you don't actually have to open the container up to stir up the flour. So the flour just stays in there and it'll tumble itself. We usually will spin it once a day just to make sure the flour gets agitated, instead of going into the bin and sticking your hands in there and fluffing it up. Now you don't have to fluff it up, but if you don't, you end up with that cake type cure, and it's everything stuck
breaks up.
And then you risk not getting enough moisture removed from the bottom of the container. So the turning of the barrels is, for us, super important.
And that kind of plays into how we know that the room environmentals can be way fluctuating. So if you crack that open during a high moisture point or a low moisture point, you're gonna work harder to reach that equilibrium. Whereas if you can just agitate the cannabis in place while allowing the cure puck to do your curing and burping for you, it's kind of like you don't even need to worry so much about the room environmental, because you're creating your own tiny room for that cannabis itself.
Certainly. And so we do encourage people to maintain a specific environment in the room, because if the room gets over a certain, because you are exchanging air with the room air. So for us, if you can maintain close to 58% RH, results typically are great. Temperature is also important. If you have the temperature too cold, people like to just talk about cold curing, which is good. It's fine. The challenge is you don't get the same enzymatic activity when it's cold. So you can notice that if you have a cold room, the CO2 is very slow to be off-gassed. And so you slow down that. And if you get too cold, you actually stop it. None of the enzymes don't actually do anything. And if you get too warm, then you get other bad effects. Like it's just, you don't want to. So for us, we try and stay between, if we're talking Fahrenheit, we stay between 62 and 72. Our perfect range is 65 to 70. And then as far as RH, we try to keep the room around 58. And so flour with a water activity of 58 is typically good in all situations. Some people want more moisture, so they want a little bit more moisture in it, so they'll go up to 60. It depends on the market. Some markets are interesting, like in, say, Arizona, or places where they're used to, or Colorado, where they're used to dry flour. Having flour that has a lot of moisture in it to them seems strange. Like they think it's too wet. Whereas in other markets, say certain parts of the California coast, that flour is way more sticky. So, and you can adjust that obviously with the settings in the cure puck.
That is awesome. And one thing that I'm curious about is we have all these data metrics, and we're getting this data through the web app or through the phone app. Is there any way for people to integrate that data into existing data collection tools like Arroyo or something like that?
Yeah, so there's an API on the Cure Puck software. So on the Pro model, which is what we're looking at here, you can send the data out to, say, Microsoft Business Central, or to a screen for, say, you had a TV screen in your room, you want to put all the data up on a screen, you can do that as well. Yeah, there's a lot of options there.
That's super cool. One thing that I want to get to, so after, say, all the cure went great, we used the Cure Puck. Oh, actually, one quick question. Could you use maybe one or two cure pucks, gather the metrics, gather the data you need, and then just set your practices in that way, instead of getting a bunch of cure pucks and trying to kind of bin out all of your stuff? Would it work to just get one or two and then kind of set your practices off of a few cycles of that data?
Yeah, sorry, I'm just getting a bunch of pop-ups here.
Yeah.
I think it's your guys' pop-up.
Yeah, we like to
survey. So what's common is most people will buy. So there's two ways of doing it. One is people don't know why they're curing. They don't know how to cure. They don't know when to burp, how long to burp, what they're burping for. Someone showed them how to do it one time, and they kind of just follow that. So they follow their teaching. So there's that side, and there's the other side who they've got it all figured out. They know that if they burp every day for twice a day, and they do that for six days, then their flower turns out perfect. So if that's the case, you can program the CurePuck to do exactly what you already do and just automate that. On the other side, if you don't know what you're doing, which is the most common, or you don't know why you're doing it, people will use the CurePuck to learn. So first thing they'll do is they'll use the CurePuck to learn how to control their dry room better and get better output of their dry room. So they'll actually just put the puck in the room. And then once they're done drying, they'll go and put the puck into the chamber. And then from there, they will typically buy one and get things figured out. It usually takes about three rounds, 3 harvests to get everything figured out. There's just some bit of a learning curve. And so by the 3rd harvest, you usually have it figured out. And then from there, some people will just use what they've learned and just scale that to what they're doing, or they'll buy, say, 10 more and try a bit bigger test, and they'll buy 10 more. And then eventually there's companies out there that got hundreds. So it's, it all depends. And so for us, there's flower right now in some, we're always curing. There's almost no time where we're not trying to cure, and we're trying to perfect it. And we're learning all the time. And curing's one of those things that no one's got fully figured out. I think we have a big chunk of it figured out, but there's still a lot to be learned. And so we're constantly testing, we're constantly drying, we're constantly curing. And so right now there's flower, like the bucket right beside me with flower in it is curing. And so, the learning piece is, for me, the most important piece.
And one thing that, I think this is an amazing tool for is, sure, you have a very good standardized dry process, cure process, but you're running multiple different strains. A lot of the times you're getting strain turnover of like 20 to 40% of the strains that you grew last year are not the same that you grew this year. Mm-hmm. So if you were to use this CurePuck to adjust your metrics as you adjust the strains that you're offering, you don't have to guess, and you can always be sure that you're getting the optimal amount of cure time, optimal amount of cure environment for every different strain, which is kind of nice.
Totally. Or even the other side of it is just being consistent on it. So I'll give you an example. Like this weekend, I'm leaving for 3 days for the weekend, and we have some flower here. And if I didn't have the pucks, I would have to have someone come and burp these containers. And so it's just going to burp automatically over the weekend. And I can actually go and burp it myself from my phone if I had to, if I found that, I didn't turn the program on or whatever. So I'll automatically burp it. So there's just these things. If you're burping on the weekends, not a big issue, then CurePuck's probably not for you. But if that's important, then there is a big advantage to it.
That is cool. So you get remote alerts, you get a full dashboard, and you also get remote control over the burping process.
Yeah, so there's some settings, and we're constantly improving the firmware and the software that work with it. So for instance, say you loaded flour in there that was too moist or too wet, and the CurePuck's going to try and pull that moisture out as fast as it can. And let's just say it can't because there's just too much moisture in there.
Right.
So the CurePuck will send you an alert saying the flour is basically too wet. You're going to have to do something about it. And we've been trying to burp the gases out, and we can't. There's just too much moisture coming out. So that'll alert you to do that. So you can go and take the flour out of the barrel, maybe put it on a rack, or just let it breathe more. Or say the room gets too hot, it'll give you an alert that the room overheated, and so you have to get back there and do something about that. Or so anyways, there's a numerous alerts that you can have that'll alert you of important things that will affect your cure.
Awesome. And so we have our cured bud. We've found the metrics to cure it perfectly. But we all know that even in a batch of 1 pound, that entire 1 pound of cannabis is not going to be great. We have to pick out some either stemmy stuff with crow's feet. Maybe there's a little bit of PM on 1 or 2 buds. That's where the sorting and the grading comes in. Historically, we've used like metal wire grill racks or the band sorters, things like that. What is some of the solutions that you have for sorting? And can you go over the importance of grading? Sure.
So sorting has been, obviously in the last few years, become very popular. Sorting out size, smalls. Some facilities sort for 3-4 sizes. And so band sorters there's a vibratory sorters. There's a few sorters that came out initially. Then there was these band sorters that came out, and they worked well. The accuracy wasn't there for some of the people. Like some people want like really extreme accuracy. And so the accuracy wasn't there. The maintenance on them is hard. The bands break. They're hard to clean. And so we decided we needed to make something that was more accurate, faster, more reliable, lower maintenance costs. And so we call it the S1 sorter. So it's just and it's got an auto feeder. So you load 50 pounds in the auto feeder, you push go, auto feeder feeds the machine, it sorts it into up to 5 sizes. And so yeah, it's a really effective way of sorting. And then from there, we realized that there's a piece of the industry that is, we actually started this 5 years ago. So if you look at any industry like blueberries or almonds or fruit nuts, tomatoes, they are all at some, well, not all, but most of them are optically sorted or optically graded. So they use like some cameras or some lasers, and it will sort the good from the bad. And so this was really important, obviously, for numerous reasons. But the challenge with cannabis is it's so nuanced. We tried adopting, for our own needs, one of those systems, the blueberry sorter, over to cannabis. The challenge is blueberries they're blue and they're round, or they're not blue and they're not round, right? And they're all the same size. And so it's not too hard to differentiate the differences in good and bad blueberries. But cannabis, because there's so much nuance to it, there's different colors and sizes and shapes and crow's feet and stem and structure issues and all these things. And it's so fickle that those devices wouldn't work. So we had to develop something from the ground up. So 5 years ago, we started looking at how we can do this. And last year, we launched what we call Marvel. So Marvel is a grading system that uses AI and vision to sort and grade and size sort and actually grade cannabis at high speed. So it'll do up to 100 pounds an hour. And so what happens is the flower will go through a conveyor system. It'll fall through an array of cameras. The cameras will take images of the flower on all sides, and it'll decide based on your criteria what happens with that flower. So if it's perfect, it'll fall straight through and go out to the good stream. If it's got, say, too much stem, and stem is, you have a really strict criteria on stem, it'll kick that out with a puff of air, it'll kick that out into a different stream. There may be crow's feet or leaf. You want everything to be perfectly trimmed, so that'll kick that out to another stream. Maybe powdery mildew or bud rot is an issue for you. Maybe you're growing in a greenhouse. It'll kick that out into another stream. And maybe size. Maybe you don't want anything under the ½ inch to go into your good stream. It'll kick that out. And so you can adjust all these parameters, or even color. Like a common thing recently is color is very important. And so if you have some, let's say you have like a gelato or a cherry strain or something that's purple or red, the value of that goes down dramatically if you have a bunch of lime green stuff in there. That's why you see all these under canopy lights and all these ways of trying to get that lime green stuff darker and bigger. And so a lot of people will separate out those colors, and they do it manually, and that takes a ton of time. So we had a customer recently, they spent $100,000 over 3 months separating out the purple stuff from the lime green stuff.
By hand?
Yeah, by hand. And for them, it was worth it because they got enough out of the better quality flower that it was worthwhile to them. And so for them, they could have used Marvel, and Marvel would separate out all the purple stuff from the green stuff. Or and so there's a lot of use cases for Marvel. It's custody transfer. Say I live in Vancouver, Canada, and I'm sending flower to Spain, and the person over there wants to buy flower from me. I can run all the flower through Marvel and then send them a printout of exactly what is in there, the size distribution, the color of it, everything, every visual characteristic. So if your eye can see it, Marvel can see it. And so we can train Marvel to see anything your eye can see. And it's becoming very useful for a lot of facilities. So like this one image on the right here, that facility, they're hand grading all that flower. So they're going.
You see that everywhere in large grows. Yeah. Seasonal workers going through giant conveyors where there's no way they're taking a look at every single, but there's no way, There's
no way. Because like first, at the very least, they're only looking at half of the flower because it's whatever they're looking at the top side of it, and then they're only be able to grab every so often. And so, if in some of these companies, like if a consumer gets, especially if you have your own brand, if a consumer gets a flower that's got mold or any imperfections in it at all, really nowadays, that's going to hurt your brand. And so the brand protection piece is really important for a lot of people, and that's why they're adopting Marvel.
That's awesome. I do recall you having one of these machines behind you. Is there a way that we could take a look at it in action here?
Yeah, sure. So we will, I'll get these guys to move the camera over there. So there's a few things we can do. I think what we'll try to do first is we'll separate out a green flower, a purple flower, a flower that has stem on it, too much stem, and one that is yellow. And so you'll see the screen there which shows the flower being sent through it. They're going to drop the flower on that top vibratory conveyor. It's going to fall through an array of cameras. And again, this can do this extremely fast. You'll hear the jet, the air pulse hit. Yeah. And so what it's doing is it's separating those flowers into the different streams. And so
it saves the images too. So you don't have any question. Like you can always go back and refer to those pictures.
Correct. So if you had, so right there, the one on the right, I believe, is the purple one. The next one's the green one. The next one to the left is got a stem, and the last one there is, I reversed it. The second one was the yellow, and the last one's green. And so if we were to look really close at that criteria, it would see. Let's see. There you go. So it split them out into the different. So the one conveyor on the right is the perfect conveyor. The one conveyor, that one there is perfect. That was what we wanted. That was the purple flower. That one is yellow and stem. So those got kicked out on the other path. And then in the other bin, which has got some packing peanuts in it, is the small lime green flower. So that was too small for our batch.
That's awesome. That's like 5 people's worth of work being done like all at once at the same time with a photo, because it's not like you can get your sorting staff that's seasonal to take pictures of everything they're pulling out, but this machine actually can.
Keep it. Totally. Can we put an analytical mode? We'll show you. So that's just showing the image. If we go to analytical mode, it'll show you the distribution of everything that went through there. And so what you want typically is you want not very much red. So red is failed our criteria. So in a perfect world, everything that goes through here, you have a lot of green. If you start seeing a lot of red, then you know, okay, that this batch wasn't as good. And people are starting to tie this back into their cultivation practices. Like, why is the flower a little less purple this time than it was last time? Or this batch here would be perfect for a certain customer.
That's cool. And one thing that I'm wondering is, like you said, the markets are different in each state. Is there a way that these metrics can kind of be adjusted per grower specifications?
Totally. So like, for instance, so every facility I've been to has a different grading standard. So I haven't seen a single, well, maybe there's a few, but there isn't really a well-adopted grading standard. And so what we can do is we can either use the standard that we're creating now, and you can use that as your in-house standard, or we'll go and adopt Marvel to work with your standards. We can program it to have your standard that you're using, or your grading methodology. And so, and we can program it to do new things. For instance, foreign objects. Let's say I bought, like a tip of a glove, for instance.
Yep. So many blue tips in trap bags I've seen.
Yeah, and so stuff like that, it'll detect foreign objects, tips of gloves, pieces of trellis netting, perlite. We can't do it yet, but at some point we'll be able to detect bugs, trichome density. So there's these other things that are on our path. So we'll be able to see how dense the trichomes are in the flower and actually give you a grade for that. And
so you can make like amazing bags, and then you can make B grade bags for like pre-rolls and stuff like that.
Totally. As well as if you find something new, like we had a customer in Australia, and the Australian sun is really bright and hot, and they were getting some weird photo bleaching. So they wanted to pull out this white flower that was getting photo bleached.
Oh, right.
And so on one hand, people will think that this is for only those who are using, say, automated trimmers or automation, but we're actually seeing a lot of companies who are hand trimming use this as well, because again, the hand trimmers are kind of the last line of defense. And if someone didn't care that day, or maybe made a mistake, and you get that one not so great shitty flower into a bag or into a package, then that's going to hurt your brand. And Reddit reviews are obviously important to most brands. So
reputation makes or breaks it, like consistency
100%.
is so key in this industry. As more and more people become consumers of cannabis, you want to make sure that they get what they expect to get when they purchase your product.
100%. Brands are built on consistency. So,
and one quick question. So you mentioned that you guys are constantly adding new stuff. So when you get a subscription to the Marvel service, like basically you're going to continually update it and add these features in for free? Yeah.
So now there's certain things that may come down the line that if it takes us a ton of extra development effort, then it might be an add-on. But now everything that we're launching or releasing, everyone's getting that. So
that's cool.
Yeah. So we've taken millions of images of flowers, so our data set's getting quite large, and so we still see new things constantly, but we're getting less and less. So the model's getting really strong.
That's really cool.
Yeah.
Well, I mean, that is pretty cool how far we've gone on the post-processing side. I really hope the bulk of the industry starts to understand these concepts and starts adopting these tools, especially if you make it easy, like CurePuck's having an API that already integrates into other systems, like the control that you get over the web app. So, I mean, I'm looking forward to seeing how cannabis comes down the line in the next year or so as people start to adopt these more advanced tools in their cultivations.
Certainly. As am I. I think there's still a lot of innovation in the cannabis space until we get to be on par with other industries, like I said, blueberries or almonds, or there's so many things we still can do to improve, and I think we're just still scratching the surface on that.
Totally. And I'm glad that you guys are there at the front, man. It's going to be a good time.
Yeah.
We got quite a few questions here too. I definitely want to get through these here. Marco, you there? Hey.
Oh yeah, I'm here, guys. That was amazing. Thank you for sharing, man. We're getting a ton of really great comments and feedback from everybody. So, wow, Jay, that's incredible what you guys have coming out, going on up there in Canada, and excited that it's available now to the world, to the industry. It's just going to continue to grow the industry and make it more legit, and really in a lot of cases provide medicine for those that use it as medicine as clean as possible, and you know what you're going to get. And so yeah, let's just jump right into these questions. Okay, so Chris Lowe is asking about the advantages and disadvantages of wire tumbler versus twister tumbler. What do you say to that?
Okay, wire tumblers. So yeah, there is different tumblers or different ways machines are built. We use a metal screen, and then there's another machine that uses a wire tumbler. So the wire is great for getting really tight, close trim. The disadvantage is it gets a really tight, close trim, and so it'll often over trim the flower. The other challenge with wire is it's not easily to clean. Like, while you can see it looks clean, but if you look under a microscope, it's very difficult to clean. So there are disadvantages to it. So the pro is it can trim really tight. The con is it over trims typically. You get that really rock polished flower.
Yeah, I hate that. I hate seeing bags like that. It bums me out.
Yeah, we all do. Okay, cool. And Miles Mendoza has a couple questions here. Miles was very enthusiastic in the chat, so thanks for joining us today, Miles. This is wonderful that you joined us. I guess it looks like he's wondering if there's any in-person demos available. And then, yes, I will have a recording available after this is done. Usually takes about a day and a half or so, Miles, but we will have the recording will be done and available on our YouTube channel, Cannabis Research and Development. We've got all of our webinar series there. But Jay, are these demos available? Like, I guess in person, I would imagine they have to come up to Vancouver, or do you guys do demos in, like, any partner facilities in the US here, or
so a few things. One is we do demos in our facility here, our facility in Vancouver, Canada, usually monthly. And so we welcome anyone at any time to come visit us, and we'll show you whatever you want to see. We'll show you around Vancouver if you want to see Vancouver as well. We also have a facility in Ferndale, Washington, which we don't typically do many demos at, but we could host people there. We also have partners in California and in Michigan that will demo a lot of our equipment for you. We also will occasionally come out and do an on-site demo, depending on where it is and who the customer is. So we do that as well. We prefer to do demos here because we know we can control the environment, we can control the flower, and so we have all the equipment here. So it's a good place to come visit.
Pretty fancy showroom too. I saw in the camera there, you guys have like a nice little like galley area, and I'm sure, man, I wish I could come up and visit you guys someday. That'd be amazing. Okay, awesome. So Pat Fenley is asking about the Cure Puck. Basically curious about that it measures the data within the room as well as the curing vessel, which is obviously pretty important. You guys kind of spoke already in length kind of about that, but if there's anything else you want to add, feel free.
The data for us, the data tracking, for me personally, data tracking is really important, because without that, it's hard to really make improvements, right? And so for us, looking back at the graph and seeing what happened and trying to mimic that the next time is critical. It's and then troubleshooting, like what went wrong. We often will find times where, and that's how we learned actually that the flower that's more dense needs to have a little bit less water activity. Otherwise, it gets that we couldn't figure out why that functional was happening, because we're trying to contain as much. Our goal has always been to contain as much water as we can in the flower, and so for it to still burn well, the stem will still snap, and it has that bound in water. And if you obviously keep too much water in there, you're going to get these negative effects. And so finding that fine line for us, the data the graphs were really helpful in that.
Awesome.
Great. Go ahead.
Oh, sorry. I wanted to kind of, I think these two questions, the next two questions from Pat kind of mesh together. So I kind of wanted to mesh them together just on the fly. Like, it's a good question. When you open the vessel that has the cure puck in it, will it skew the data at all? And at the same time, what is the optimal range that outside environment that the cure puck vessel is in should be?
So it will, you'll see it on the graph typically. So what'll typically happen is when you open, if the room is, you'll see a change, a pretty rapid change in both the CO2 and the room environment. So you can typically tell where the chamber was opened. We really encourage people not to open it if you can, but obviously it's like people just want to open it. So we get it. And then as far as the room goes, 58 RH, if you can maintain a room of 58 RH, that's ideal. And then temperature between 65 and 70 is ideal as well. We often get up around 73 Fahrenheit in the final stages, mainly because at some point the flower is going to be in that environment. So we want to get it into that environment under control and then allow it, because often people will cure in a cold environment, everything's great, and then they move it somewhere warm, and then all of a sudden it starts sweating out that moisture, and you get these issues.
Thomas Wong, he has a really good question, and I think the data from the cure pucks kind of answers this question too. Is like, when do you know the product is officially done curing?
Yeah, good question. So for us, there's two things that often happen. Number one is, we see this the most, and I share this already, is people will load the flower into the puck, and then the CO2 won't climb and the RH won't move. Well, we call it cooking your dry. So you've over dried your flower, or you've done something wrong in drying, or you missed something in drying, so now you can't cure. So let's just say you did it well and the flower comes from the dry room at a decent moisture or decent water activity, you load it in the chamber. We'll often see the CO2 climb to 1,000, sometimes 2,000 ppm, and then our goal is to keep burping that down. So when the CO2 stops climbing, that's one indication that the off-gassing is done. And when the RH starts to stabilize, that's another indication. And so we typically see that on our best runs, it's usually 10 days, sometimes 14 days, but typically 10 days is where we find that all the markers are solid.
Starting to level out. Okay.
Yeah.
And you'd never know if you didn't have that cure puck in there. Like, a nose is a nose, but hard data is the way that I like to look at things, and that's all.
And there are people who find that they'll go an extra 2 weeks, 3 weeks of just like a burp a day, like a quick burp every day, just to get that action, because there is a potential that there is a gas that we aren't measuring, right? So there might be a gas that we haven't discovered yet that's causing these issues. And so just to be sure that isn't an issue, they'll burp for a longer period. And yeah, so for us though, like because we're typically more a little bit on the, I would call us a craft producer, a little bit more on the commercial side, like trying to be really efficient. And so time for us is important. So it's usually a 7 to 10 day dry, usually 10 days, and then a 10-day cure.
Awesome. Quickly, we can export the pictures out of the Marvel AI once the pictures are done.
The pictures are saved in the cloud. They're fully, you have access to them. You can do whatever you want with them. 100%. Yeah.
And being being like a networked piece of equipment, all of the updates that you would want to have, you could push them into each individual Marvel device, correct?
Correct. Typically what we'll do is we'll get the parameters of the request from the customer, what they want, and everyone's different. So we're trying to adopt, and that's one of the challenges we have right now, is adopting this to everyone's different needs, which is great for us because we're starting to build this really big library of things we can do. But yeah, if you have specific needs, we can adopt it for you.
Cool. And just back to the vessel that the cure pucks are on. Just to reiterate, what is the percentage of volume in that vessel that you recommend people fill?
Again, so yeah, well, the biggest mistake we see with that is people will not put enough material in there or too much. And so if you were to put, say, an ounce in a 35-gallon drum, well, you're not going to affect the headspace for that ounce at all. The headspace is going to control what happens in there. And so 50% is minimum, 75% typically is maximum. So you want, for us, it's over 50% usually, and less than 75. And it doesn't have to be perfect, but you just want to have enough headspace in there that you can measure the gas in the water, the moisture in that air, and allow the flower to affect that headspace. So if you don't have enough flower, it's not going to affect the headspace. The headspace is going to affect the flower.
Awesome. And then one last quick question from Miles. What's your opinion on the white ash debate? For me, it has a lot of different parameters to go into it, but how specifically does the dry and cure process go with the quality of the consumption of that product?
Yeah, we've looked into this a lot. We've tried a lot of different tests.
It's such a loaded question, man.
Yeah, like I know for a fact, if you heat something hot enough, you'll make white ash. So
Yeah.
like that's one way of doing it. The way the grind size is another important one. What fertilizer is like? Is there phosphorus still in the flour? Yeah. Is there nitrogen still in there? Like flushing for us, we know when we flush we still sometimes we still flush for the last week, but we notice that doesn't make a big difference in our ash. We have to start lowering fertilizer really early, like in the last 3-4 weeks, and dramatically lowering it, and we'll get white ash almost guaranteed. The challenge is our yields go down, so we're trying to find this balance there. With curing, we certainly notice if you cure longer, we get a better ash. If there's too much free moisture in the flour, that moisture will make a darker ash. So trying to stabilize that moisture is really important in getting it locked in the right way is really important for white ash. So there's a lot of things you look like the cigarette industry for a long time. Like that's what I
was going to say. I always refer back to the tobacco industry because they have a bunch of research done, replacing your nitrates and phosphates with magnesium. Grind size, cure time. It's such a holistic measurement. You can get the exact same bud, and like you said, I could roll you a joint that will be completely black and not burn great, and then I'll grind it just right and make it white ash cone on top like a cigar.
Totally, and even like the papers you use, there's certain papers that they trick you into thinking of white ash because the ash in the paper will stick to the actual to the cherry. And then another one that's common is what was I going to say there? White ash. I lost my train of thought. Sorry.
There's too many things to go over, but definitely the cure process and the dry process does play a role.
Certainly.
Much more than that, but you should try to lock in that dry and cure process to obtain those results.
Well, that's what I was going to say. If you look at some old ads for cigarette companies, they'll often show like the cigarette with a big white cherry on it. Like that was their way of marketing like quality, right? And so they put a lot of
tobacco,
they put a lot of effort into making white ash. So I think in the end, the white ash is an important part of curing, but there's so many other things like preserving the terpene profile. Like that's a big one that people don't talk about. Maybe we talk about this really quickly is the terpene profile. So if you were to, what I find is if we have flour that we dry, if we over dry it, and maybe people on this call will have experience like this and maybe help us figure this out. But if we over dry flour and then we cure flour really well, the flour that's been over dried will often have a better nose. It's way stronger. But what we've noticed, if you fast forward 2 months from then, that flour that was over dried loses all its nose. And the flour that was cured well, as soon as you bust it up, has an incredible nose. And so like people will go and say, well, my cured flour doesn't smell as good as my other flour. Well, fast forward 2 months and then tell me if that's still true. And we find that what we believe is if you look at a trichome that's been over dried, it's just a shriveled up little raisin. If you look at a trichome that's been well cured, it'll be a little bit shriveled, but it'll still have the same shape. And there's been some studies on this where they say they believe that there's like a monolayer on the trichome head that's protecting the terpenes from evaporating. And so we haven't proven this yet, but we believe that there's something there where if you cure well, you keep the trichome head with call it more moisture and protects the terpenes in there from just being evaporated off.
Right. It's like a total volume kind of a thing. If you dry quickly, then the terpene heads kind of drop. But as they drop, they're gassing off the terpenes. So it smells great. Down the line, there's nothing there to smell great. Whereas if you cure properly, the trichome head stays more intact. So you're not going to get that great of a nose initially. But down the line, as that bud matures, you're still going to have that full terpene profile in the trichome itself.
Certainly. And another thing we notice as well is we'll notice a difference in the terpene profile. So like a really well-dried or an over-dried flower or just dried and not cured will have, I call it like distinct notes of each terpene, like a distinct, you can smell each distinct note, but when you cure well, it almost turns into like a medley, like it's a sweeter smell and they're all blended together and it has a different smell. So I think a better smell personally.
Yeah, me too. Well, cool. Is it giveaway time?
I think so. Yeah. I mean, the only thing we missed, I think, was just one of the questions about the updates on the Marvel AI. But I assume
pushed through. Yeah, we went over that. They're pushed from you guys to the Marvel machines, correct? Over the internet.
It's amazing.
Yeah.
And yeah, Jay, as we kind of wrap it up here, best way to get a hold of you and maybe your team, obviously through your website or Instagram, you guys have it all. But if you're going to be are you going out to MJ Biz this year, or are you guys planning that maybe?
Yeah, we're there every year. We're at most of the smaller shows as well, smaller regional shows. We try to attend them. We usually have someone there at least. We may not exhibit there, but we'll have someone there. And yeah, we're on Instagram. twistertech.io is our website. DM us on Instagram. That's usually a quick way to get a hold of us. Then just call our toll-free number as well. So we got some. There's people available, and we have reps in different regions. So Vancouver, back east Canada, back east the U.S., Spain, the rest of the world. We have people all over. So if you need help with something, our team's happy to help out.
Nice. Yeah. And I know a lot, like I mentioned, a lot of our team have been watching this webinar. So, they just got a masterclass in curing and a fresh refresh on all of your products. So by all means, if anybody wants to reach out to our team at growershouse.com again, we will be happy to share as much information as we can about these products. You can obviously buy a majority of your equipment through growershouse.com. Feel free to go, go directly there. Otherwise, I don't want to end this one. This has been so much fun, but
I just want to reiterate, this was one of 2 cure pucks that were given away. So if you guys want to be in the drawing for the next cure puck that we're giving out probably in a couple of days here, make sure to follow Keirton and Twister on Instagram and all the other social media sites. Follow Cannabis, Growers House Ag on all of our social media sites, and stay tuned. Hopefully the next one goes to you,
Great. Yes. And again, a quick shout out to Aaron Seminiano for helping us in the background there with the camera operating and the graphic design of the promo that you helped with last week. So anyways, it was great seeing you guys again. Jay, thank you. And Mike, thank you. I'll probably see you later this week on a call, but great. We'll talk to everyone soon. Thank you all for joining us today.
Thanks, Jay.
Thanks for having us. Appreciate it.